In this lecture, we will briefly discuss the material of the engineering workshop, the theoretical part. Now, this theoretical part you can find in the engineering workshop manual. But here in this lecture, we will try to summarize and pinpoint some of the most important points in the engineering workshop theoretical material. Okay, so the main topics you'll find in the manual a section related to the safety in the workshop, which was discussed when you came to the workshop for the first time. You will find also a part related to the measurements, the vernier caliber and the micrometer, which also was done in the workshop practically as an exercise. In this lecture, we will discuss the four workshops that we will cover starting this week. These workshops are first the machining and material removal operations. Second, the sheet metal forming. Third, the welding and metal joining. Fourth, the carpentry. Now, the machining operations is a broad term used to describe removal of material from a workpiece. Usually, or mainly, it is done on metals. So when we do material removal, we do the material removal from the surface of that metal in order to change its dimensions, its shape. Okay. There are many material removal processes. Mainly, or the most important, are the turning, milling, drilling. And these we have machines in the workshop which you will work on. The turning is where a workpiece is rotated about its axis as a single point. Okay, it is done on a machine that is called the lathe machine. The products that is the outcome of the turning is axisymmetric. So usually we do reduce the outer diameter or increase an inner diameter or do a cutting. Now, it is done in the lathe machine, and here you can find on the left the lathe machine with its different parts. In the manual, you will find a description of the role of each of these parts, and it is important. You will find from down upward, you have the bed, okay, which hold all the machine. Then you'll find the carriage, which move on the ways. Okay, you will find the headstock assembly and the tailstock assembly with all the parts that are engaged to it. On the right side, you find a picture where you find the workpiece and the tool that holds it. Okay, you find also the cutting tool and how it goes inside it. Okay, you see also the three cutting parameters: the rotational speed, the depth of cut, and the feed rate. Milling is another operation. It's done on a milling machine. And the tool here is a bit different than the tool in the lathe machine, the turning machine, because it has a multi-edge cutter. The workpiece in the turning was moving in rotational movement, but here the cutter is moving the rotational movement, and when it rotates, it cuts from the surface of the uh, workpiece. It moves here, the workpiece, in the XY and the Z direction. The Z direction is the depth direction. Here we see the upper left picture, the different mechanism of applying the milling. You have the horizontal and the vertical. You can see we also call it the peripheral, the horizontal, the vertical, the face milling. You can see how the cutting is done on the machine and the parts of the machine, the base, the knee, the saddle, the work table, the overarm or the head. The rotational movement can be done in two directions, or can be applied in two different methods. You can see on the lower right picture, you have the down milling and you have the up milling. In the down milling, the rotation and the feed are in the same direction, while in the up milling, the rotation and the feed direction is against each other. You can find more details in the workshop manual about the differences, more differences between the up milling and the down milling. Now the drilling is another machining process, and it's usually done to make holes. So the movement in the workpiece is only in the depth direction. The cutter is moving the rotational direction. Okay. You can see how the cutter has a helix cutting edge. So the drilling is to make holes or to increase hole diameters, and that's called reaming. You can see here the drilling tool and the reaming tool on the left, while on the right you can see the parts of the drilling machine. Can see the spindle, the shock, the depth stop, the table. These are the main parts of the drilling machine. The cutting tools for all machining operations, turning, milling, drilling, other like polishing, grinding. Okay. The cutting tools will either have one or more cutting edges. One for turning and more for milling and drilling. A cutter should be made of a material that is harder than the workpiece material, or else it will break. Materials commonly used for cutters are steel, low carbon steel, high carbon steel, and high speed steel. The high speed steel is very common. Usually it's used for soft metals like aluminum, like copper. Okay. And it is cheap. Now, other materials are stronger but are more expensive, like cobalt chromium alloys, cemented carbides, ceramics, cermets, and polycrystalline diamonds. During the machining process, there will be a ship formation, and you can differentiate by the shape of the ships of different machining operations. Now, here is a picture that shows how does the cutting tool make the cutting in the workpiece. Either the lathe in the turning or the machining or the drilling. This picture resembles it all. You can see the tool is working inside the workpiece. So it has a depth inside it. And it moves toward it. So it will form a shear plane. On that shear plane, on the side that is against the tool, there will be a tension force that will cause the fracture, and the other side, there will be a compression force. And you'll see how the shape forms. Okay. The parameters here are the forces, the depth, and the angles. You need also to know that there are relief or clearance angles which prevent the tool from making friction with the newly formed surface of the workpiece. Cutting conditions, as we said, we have three main cutting conditions: the rotational speed, the depth of cut, and the feed rate. Okay. Now, in machining operations, it is very essential to use lubricants. Lubricants can be either liquids or solids or greases. Now, the functions of lubricants are mainly to reduce friction between the workpiece and the tool, to stabilize the temperature of the workpiece and the tool, to reduce the power consumption, and accordingly the cost, to prevent rust on machine parts and cutters. Lubricants should not chemically react with the tool, the workpiece, or any of the machine elements. Now, the new surface of the product after the material removal should be as smooth with less roughness as possible. But sometimes that's not reached properly. And in this case, we call that this is a defective surface. The defect is when we have an incorrect working parameters, or the cutter, these are the causes of the defects, or the dull cut, we have a dull cutter, or we have an unsecured workpiece. There is a defect, okay, that we can see here also in the picture. This is called waviness. It's called by excessive vibration during the process. Okay. This reduces the surface quality, increases the power consumption, increases the noise level, and reduce the lifetime of the machine tool. So we should avoid the vibration. The second workshop is the sheet metal working workshop. In the sheet metal working, there are a variety of different processes that is done to form sheet metal. A sheet metal is a shape of or a form of metals when it has a high surface area to thickness ratio. That is a sheet metal. It has a very thin thickness. Okay, usually in millimeters. There are different processes. Okay, from these processes we have the deep drawing, the blanking, metal spinning, bending, shearing. We can see here the different processes: deep drawing, blanking, metal spinning, bending, shearing. Now, in our workshop, we will mainly do shearing, bending, and a welding process is one of the welding processes is done on the metals, sheet metals, which we'll discuss later. It's called the spot welding. In the shearing process, the metal is cut with either hand shears or bench shears. Can be motorized or uses the manual power. Okay. We see how the shearing is done. We have a punch that is movable and die that is fixed. The punch moves toward the sheet and causes a shear power that, or a shear stress that do the cutting or the fracture of the sheet metal. And there should be a clearance here to avoid friction or damaging the punch or the die. The shearing advantages: its ability to make straight line cuts, its ability to produce burred and slightly deformed metal edges, its ability to cut relatively small length of material at any time, since the shearing blades can be mounted at any angle. The other process is bending. In bending, we make a deformation, an angular deformation. It's not a fracture, but when we start with the sheet, it is flat. After bending, we make there are very different major bending types, like folding, wide bending, air bending to make curvatures or an angle in the sheet metal, bottoming, roll bending. Roll bending is to make a curvature or a kind of a circular shape for the sheet metal. We can see here the bending mechanisms. Okay, it starts flat, and when we apply bending, that causes tension on one side of the sheet metal and compression of another side. Tension makes elongation, compression makes a reduction in height. So as a total, that would be an angular deformation. Here we see the angle, the bend radius, okay, the bend allowance, the bend deduction, and other parameters. Okay. There is a phenomenon that happens when we do bending. It is called spring back, which is the elastic recovery of the sheet metal after removing the force that is the bending force. So let's say we bent it a sheet metal to a 90 degree. That when the force is uh, in work, but as soon as we remove the force, there would be a recovery. So the 90 degree will uh, uh, will uh, will not uh, uh, stay 90 degree. It will go toward the flat direction. Okay, so it will be reduced. So to achieve the desired bend angle, we do overbending to overcome the spring back factor. The third workshop is the welding workshop. Welding is the process of joining two or more materials, usually metals, same same type of metal, or thermoplastic. Uh, uh, Here we apply heat, pressure, or combination of both. We use a filler from the same type of material, okay? And that filler will be melted, and melting will make the joining of these two parts. Now there are different types of welding. We have gas welding. We burn flammable gases like oxyacetylene. We have arc welding, which we will do in the workshop also. We use here electricity, like shielded metal arc welding or MIG welding. We have resisting welding, which uses also electricity. And we have other types of welding, like solid state welding, radiant energy welding, thermochemical welding. In the workshop, we will do gas welding, arc welding, and spot welding. Arc welding, as you can see in the picture, we use electrical energy, DC or AC. We use consumable, the filler, okay, that is coated by flux. The electrical energy will melt that filler, and the molten will make the join of the two metals. Now, we need a shielding here. A shielding could be a gas or can be a flux. Shielded metal arc welding, where we use a flux over the filler. That flux has the following function: stabilize the arc, generate gases that act as a shield against the surrounding atmosphere, control the rate at which the electrode melts, act as flux to protect the weld against formation of oxides, nitrides, and other inclusions, and also add alloying elements to the weld zone to enhance the properties of the weld. The gas metal arc welding, we use gases, inert gases, such as argon, carbon dioxide, helium, okay? And here these gases make the shielding of the weld zone against atmospheric gases. And we can see here in the picture the parts of the gas metal arc welding. Spot welding, it is also called the resistant welding. Here, this is mainly done on sheet metals. Okay. We overlap two pieces of sheet metal, and we make a current go through them with a high current. Okay. And when that current goes through these two pieces of metals, and the and between them, the resistance will be the highest. Resistance with current will cause heat rise and melting, which make a welding pool, or we call it a nugget. And when that molten solidifies, it causes the joining. Okay, when we want to join uh, two, let's say, a certain length, we make more than a point or spot to make it stronger. Now, welding is the most hazardous processes of the processes that we will do, which does not mean that in other workshops there are no hazards or health risks, but in the welding it is the most hazardous of them. The major risks involved with welding are heat and sparks, eye damage, and inhaled matter. So we make extra precautions in welding, like wearing protective clothing in the form of heavy leather gloves and protective long sleeve jackets, wearing goggles or helmets with dark face plates, using curtains in the welding area, and keeping appropriate ventilation. Now, also, there is a hazard of or a risk of the compressed gases that may pose an explosion or fire risk. Okay. So some common precautions include limiting the amount of oxygen, okay, at the welding area. Now, we need to know also the different welding joints and the welding defects, their shapes, and their causes. From the welding joints, we need to know the butt joint, the corner joint, the edge joint, the lap joint, and the T-joint. From the defects, we have the undercut, cracks, porosity, slag inclusions, lack of infusion, lack of penetration. Okay, the overlap, underfill, undercut. Okay, these are important to know. The last workshop is the carpentry workshop. Carpentry workshop is the process of converting timber into wooden articles, okay, and components such as furniture, casting patterns, roof, doors. So we work with wood. The wood have two main different categories. We have the natural woods and we have the manufactured panels. In the natural woods, we have two types of natural woods, the softwood and the hardwood. We need to know the difference between the softwood and the hardwood. The manufactured panels, there are a variety of different types, and we need to know them. The plywood, the MDF, the chipboard, the block board, the hardboard, and the oriented strand board. We can see here some natural woods. Okay. In the left, we see soft woods. Okay. And on the right, we see hardwoods. Okay. Here we see different manufacturing panels like the plywood, MDF, chipboard, lookboard, hardboard, and oriented strand board. Now, the processes on wood is made using different carpentry tools. Okay. These tools, they can be hand or power driven ones. And we will deal with both types in our carpentry workshop. The carpentry tools can be classified into the following categories according to function: marking tools, measuring tools, holding tools, cutting tools, planing tools, boring tools, striking tools, miscellaneous tools, electrical tools. We can see examples of marking tools like the mortise gauge, measuring tools like the tri-square or carpenter ruler, holding tools like carpentry vise and clamps, cutting tools, the chisel, backsaw, coping saw, planing tools, planners, boring tools, the gimlet, the bradwall, striking tools like hammer, nail punch, miscellaneous tools like mallet, files. We need to differentiate between the hammer and the mallet. Electrical tools, band saw, circular saw, compound meter saw, table saw, random orbit sander, belt sander. Like in the welding, we need to know the different joints or that is done to join wooden parts. Okay, and we need to differentiate between them. We have the butt joint, the meter joint, the halving joint, the mortise tenon joint, the lap joint, the dowel joint, the housing joint, the dovetail joint. Now, this is a summary for all the theoretical material of the workshops. And you can or you should actually go back to the manual to get a better idea of this material. Thanks.